So let's look at an example of a random variable that's normally distributed with some real-world context. So let's say that we know that reading speeds for sixth graders are normally distributed, and the mean is 125 words per minute, and the standard deviation is 24 words per minute. So what does this distribution look like? Well, we know it's bell-shaped, and the center is at 125, and if we go 3 standard deviations in each direction, we should capture most of our data. So I'll take 125 plus 24, this would be 149, plus 24 again, that's 173, plus 24 again, this would be 197. And here's my 125 in the center. And going in the other direction, 125 minus 24, this is 101, minus 24 is 77, and minus 24 again is 53. So this is the distribution of our reading scores, or reading speeds for sixth graders. We could add lots of information from the empirical rule. So 68% of sixth graders read between 101 and 149 words per minute. 95% of sixth graders read between 77 and 173 words per minute. And almost all, or 99.7%, read at a speed with speed between 53 and 197 words per minute. So let's answer some questions based on our knowledge of this distribution. So what's the probability that a randomly selected sixth grader will read less than 100 words per minute? So for this, I'm going to use my normal CDF function, and less than 100. So here's 101, so it's to the left of that. So I'm looking for this area that goes all the way down to negative infinity. So my left bound is well, it's actually unbounded, but I'm going to just use a really big negative number, like negative 10 to the 99th, with 100 as my cutoff on the right. The center here is 125, and the standard deviation is 24. And so I'll go to my distribution menu, and negative 10 to the 99th power, 100, 125, 24. And so that is 0.1488. Let's see. What about the probability that a randomly selected sixth grader reads more than 140 words per minute? So 140 is somewhere over here. This is more than, so we're looking for this area that's to the right, goes to infinity. So again, I'll use my normal CDF function, and the lower bound in this case is 140, and there is no upper bound, but so I'm going to choose a huge positive number, and 125 and 24 for the mean and standard deviation. So my distribution menu, I'll choose 140, 10 to the 99th power, 125, and 24. And so that probability is 0.2660. Let's see, what about the probability that a randomly selected sixth grader will read between 110 and 130 words per minute? So once again, this is a normal CDF problem where the lower bound is 110, the upper bound is 130, the mean is 125, and the standard deviation is 24. So distribution menu 2, 110, 130, 125, and 24. That is 0.3165. All right. Okay. Would it be unusual for a sixth grader to read more than 200 words per minute? So we're looking for the probability that if we pick a random sixth grader, they would read more than 200 words per minute. So let's find that probability. So this would be 200, 10 to the 99th, 125, and 24. And so, basically we're looking over here in this tail, that'd be 197 was 3 standard deviations away, and we're looking even beyond that. So this is going to be really small. You may recall, if you go back and watch a video about the empirical rule, that from here over, the area is 0.0015, and that's from 197. So I know that this answer is going to be even less than that. So I can already say this is highly unusual, but let's go ahead and calculate exactly. 200, 10 to the 99th, 125, and 24. Yes, we get an answer with an e to the negative 4. That means there are actually 3 zeros that precede this 8. So, the probability is very small. This is highly unusual. All right, what other types of questions? What if we wanted to know the 90th percentile for sixth graders? In other words, we're looking for the reading speed that separates, if we're looking at this, we're looking at, there's a 90% here and 10% here, and we're looking for the words per minute that's the dividing line between the bottom 90 and the top 10. So this is an inverse problem. So I'll go to my distribution, the distribution menu, and inverse norm, and my calculator is oriented to the left, and so I'm going to use the area to the left of that line, and that's 0.9. My mean here is 125, and my standard deviation is 24. So 0.9, 125, 24. That is 155, let's just round it up, 156 words per minute. That separates, or that is the 90th percentile among sixth graders. And what about if we wanted to know the words per minute for the middle 50%. So I'm thinking to myself, I'm trying to isolate the middle 50%. I know that that's going to leave 25% in the bottom and 25% in the top. So I'm going to use the inverse norm function twice. In the first case, I'm going to find this line, so I'm going to use the 0.25 with 125 and 24. And this line, basically, it combines the 25 and 50. That's the 0.75, the 75th percentile. And those values are found using inverse norm, 0.25, 125, 24. So that's 109 words per minute. And if I do it again, distribution, option 3, 0.75, 125, 24. That's 141 words per minute. So half of sixth graders read between 109 and 141 words per minute. All right, hope that helps. That's an example where we're using a normal distribution in some real-world context. See you next time.